So this is lesson 5 in chapter 1, and we're talking about equations. So we're just getting into sort of more solving equations and the idea of them. So here it says a mathematical sentence with one or more variables is called an open sentence. Open sentences are solved by finding replacements for the variables that result in true sentences. So if we said 3x plus 4 equals 12, we don't know what x is, so we got to figure out what that is, right? It's an unknown. And when we have an unknown in a sentence, it's not definitive. We don't know what goes in there. So it's called an open sentence until we figure out what x is, and then we have a solution. So the set of numbers from which the replacement for a variable may be chosen is called a replacement set. The set of all replacements for the variables that replace true statements is called a solution set. A sentence contains an equal sign, it's called an equation. When a sentence contains an equal sign, it's called an equation. So basically, we're just solving for x, but here we kind of add one more element to it. And instead of just saying, okay, our answer can be any number. So solve for x, which number is it out of all the numbers? Now we're limiting ourselves. So I'm saying, all right, solve for x, and your only choices are 2, 4, 6, 8, and 10. So if one of those numbers is your answer, then that's the solution. If one of the numbers that fits for x is not 2, 4, 6, 8, or 10, if it's a different number, then there's no solution because you have to be able to pick from one of the replacement set numbers. And I know that sounds confusing, so let's get into it. All right, example 1. Find the solution set of 3a plus 12 equals 39. And it's called a solution set because sometimes there is more than one answer that can go in for the variable. It's not always just one answer. But right now, it's kind of more often than not one answer. All right, so find the solution set of 3a plus 12 equals 39 if the replacement set is 6, 7, 8, 9, 10. So what they're saying is you have to solve this equation for a, but the only choices that you can use for a are 6, 7, 8, 9, and 10. So if we were to solve and get, let's say we got a equals 12, okay? And that's a legit, like let's just say, I'm just making that up, it doesn't work here, but if we were to solve and 12 was the solution for a, since it's not one of our choices, then there is no solution because out of these choices, we're saying which one of these works. And if none of these work, then there is no solution. If one of these works, or if more than one works, then we're gonna name it, okay? And we'll talk about how to do that. So here as an example, replace a in 3a plus 12 equals 39 with each value in the replacement set. So we're gonna plug 6 in for a. 3 times 6 is 18, 18 plus 12 is 30. Does that equal 39? No, that doesn't work. So that's not a solution. How about 7? 3 times 7 plus 12 equals 39. 33 equals 39. That's also not a solution. 3 times 8 plus 12 equals 36. That is not equal to 39. Still not a solution. 3 times 9 plus 12 equals 39. So that is the solution because it actually ends up being true. 39 does equal 39. That's true. So 9 works. And then, of course, 10 is not going to work. So the only one of these replacement set numbers that works, that makes this a true statement, is 9. So when we write our solution set, I guess you could say, we write it with these little squiggles around it, okay? If it was just x equals 9, we would write x equals 9. But since we're using the notation for replacement and solution sets, we always put them in these little squiggles. So if our answer was like two numbers, let's say it was 8 and 9, we would put 8, 9 inside these little squiggles. And just anything inside these squiggles is a solution to this equation based on the replacement set. And again, there could be another answer that's not given to you as a choice. And that's okay. If it's not one of these numbers, it can't, then you just say no solution. There's none of these solutions work. So you would say no solution. And then, of course, an equation, just to kind of review, is any problem with an equal sign. And here we don't have a variable in here, right? All of these are numbers. So it equals, and that's the unknown by itself on one side. So whenever we have that, we just call it an equation. And you just solve like normal using order of operations. So we're going to go down here and try a few of these. All right, so our directions here say, find the solution set of each equation if the replacement sets are, and you're going to see this a lot, where they give you x equals these or y equals these. Okay, well, what does that mean? Well, if you start looking at these equations, this one says y minus 2 equals 6. There is no x, okay? So we're not going to look at this x part. We're just going to look at the y part, okay? So I'm actually going to highlight the x one in yellow. And then out of all these, I'm going to do 9 problems here. Out of all these 9, I'm going to highlight the ones that have an x in them. So I know which one to use that replacement set for. This one, y, that one's an x. Okay, that one's all of them. So there's 1, 2, 3, 4, 5 different problems out of the 9 that we're going to use for x here. I'm going to try and zoom in a little bit just to focus. Okay, so our only choices to put in place of the variable are 1/4, 1/2, 1, 2, or 3. That's it. So if I were to solve this, honestly, and you don't have to, I meant to say that earlier, you do not have to go through the trouble of substituting in every single one of these and then putting it in here. You don't have to do all that extra work. Just solve for x like normal. Solve for x like normal. So you know what x is going to have to be. And if that number that x has to be is also in this replacement set, then that's your solution. If the number that x is supposed to be is not here, then there's no solution. That's it. But don't go through all this extra work. Just solve for x like normal. And if it's one of these replacement set choices, then use it. Okay, so back here to this one. So I'm just going to solve for x. And then if it's one of those 1/4, 1/2, 1, 2, or 3, then I know that's the solution. X plus 1/2 equals 5/2. I subtract 1/2 from both sides, and I get x equals 4/2, right? Which I can simplify. 4 divided by 2 is 2. So x is going to equal 2. Is 2 one of the solution choices that I have here? Yes, it is. So my solution set is just one number, and it's a 2. So I would write it like that with the squiggles around it. That's my solution set. The one below it here, x squared minus 1 equals 8. I'm going to add 1 to both sides, and I get x squared equals 9. And then I have to take the square root. Now, I don't know if you guys remember this. I'll write it down here. X equals, whenever you take the square root of a number, the answer could be positive or negative, right? If x squared is 9, x could be -3, because -3 times -3 is 9. Or it could be +3. +3 times +3 is 9. Excuse me, it could be either one. So we always put plus or minus 3, because it can be positive or negative. However, one of those is not one of our choices, right? -3 is not one of our choices, only +3. So over here for our solution set, I'm going to write a little squiggle, a 3, and a squiggle. And that's it. That's my solution set. Even though there's another answer, it's not one of my choices. Okay, number 2. X plus 8 equals 11. I subtract 8 from both sides of my equal sign, and I get x equals 3. So is 3 one of my... Yes, it is. So I put my little 3 inside my squiggles. It seems like a funny thing to do because we already know how to solve for x, so why would we go through this trouble? We normally won't. You probably won't. There are times with data and different things that you might, but you just need to know how to do it if you encounter that type of problem, but you typically won't. All right, number 5. Oh, that's a y problem. We skip that. Number 3. Nope, 4. Sorry, 6. X squared plus 5 equals 5 and 1/16. X squared plus 5 equals 5 and 1/16. So I'm going to subtract 5 from both sides of my equal sign. And I'm going to get, so this 5 goes away and this 5 goes away. So I'll get x squared equals 1/16. Let's scoot this over. Okay, and remember our rules of radicals. If I put this fraction under a radical, I can actually separate it, the radical, into the top and the bottom. If I take the square root of 1, it's just 1, right? Because 1 times 1 equals 1. And the square root of 16 is 4, because 4 times 4 equals 16. So my answer here is 1/4, right? And it could have been positive 1/4 or negative 1/4. But in my answer choices, I only have positive 1/4. So even though the solution, oops, just like we did the problem with the 9, even though the solution is positive or negative 1/4, my only choice is positive 1/4. So I put that in those little squiggles. I'm terrible at drawing those. Okay, so those are all the x's. We can go back and look at the y's. It's all going to kind of run together, but that's okay. So for y's, our choices are 2, 4, 6, and 8. And this study guide is here in this folder where you're watching this video, so you can always look at it if it helps you to follow along. So our only choices for y are 2, 4, 6, and 8. So here if I solve for y, I add 2 to both sides and I get y equals 8. Was that one of our choices? Yes, it was. So I put my little solution set in squiggles. Okay, going down 1. Oops. We're going to save this till the end because this is a tough problem. So let's go to number 5 here. Y squared minus 2 equals 34. I'm going to add 2 to both sides of my equal sign. Y squared equals 36. If I take the square root of both sides, I get y equals positive or negative 6. But of course, negative 6 wasn't one of my choices. My choices are just 2, 4, 6, and 8. So I put 6. Oh, I skipped number 7 down here that had an x. Let's go back to that for a second. Here I'm going to multiply. I'm going to distribute my 2. So I'll get 2x plus 6 equals 7. I'm going to subtract 6 from both sides of my equal sign, so I get 2x equals 1. And then I'm going to divide both sides of my equal sign by 2. That's squishing in there, sorry. So if you notice, my answer is actually going to be a fraction. X equals 1/2. And was that one of my answer choices for x? Yes, positive 1/2 was, so I can put that in squiggles. When you're writing it in this solution set notation, you don't write x equals. Just literally whatever it equals that's part of your choices, you just put that number inside squiggles. Okay, so we're done with the x's. Back to y's. Here I have y plus 1 squared equals 9. Well, what I notice is this entire side is being squared, and this entire side is a perfect square. So I can actually take the square root of both sides. So when I take the square root of y plus 1 squared, I just get y plus 1. And when I take the square root of 9, I get plus or minus 3. So now I'm going to subtract 1. If this was a positive 3, 3 minus 1 is 2. If this was a negative 3, negative 3 minus 1 is negative 4. So those are my two solutions, but out of my choices, I only have positive 2, 4, 6, or 8. So negative 4 is not a choice. So my solution set for this problem is just 2 inside squiggles. And the number 9. Okay, so this one's a little more complicated just because it's a quadratic, so we have to solve it, and it uses a little more space than I give myself. So we're going to, when you have a variable squared, a variable to the first power, and a plain number, that's in quadratic form. So we want to get everything on one side of the equal sign and a 0 on the other side. So I'm going to subtract 20 from both sides of my equal sign, and I get y squared, sorry, my dog's barking, plus y minus 20 equals 0. Okay, so now when I want to solve this, I have to factor it. Strike us. I have to factor it. So I come up with all the factors of the last number that add up to the leading coefficient of this middle term here. So this is a 1. Since there's no number, this is a 1. A plus 1, so it's a positive 1. So what factors of negative 20 add up to positive 1? What about 5 and negative 4? 5 times negative 4 is negative 20. 5 plus negative 4, 5 minus 4, is 1. So that works. So I'm going to write y plus 5 and y minus 4. Hopefully you guys remember how to factor. We will get a chance to review that a little bit this year, but hopefully you guys remember. And then once I get to this step, I just set each of these parentheses equal to 0 because of the multiplication, multiplication property of 0. Anytime I multiply a term by 0, the answer is always 0. So I don't know if this guy's 0 or if this guy's 0, but one of them is, right? So if I set this equal to 0, that means y has to equal -5. If I set this term equal to 0, y would have to equal +4. Well, out of -5 and +4, which ones are part of my answer choices? Just +4. So even though there's still another answer, it's not one of my choices. So in the squiggle, I put the 4, and I'm done. So it's just solving for a variable like normal, but your choices are limited as to what numbers can be the solution. Okay, and then down here at the bottom, this is just solving equations. So I'll do a few of these, not all of them, and then we'll flip on to the back of this worksheet. So I have a equals 2 to the third power minus 1. Order of operations, I do exponents first. 2 to the third means you're multiplying 2 3 times. So 2 times 2 times 2. So that is 8, and 8 minus 1 is 7. And there is no solution set or replacement set here, so I can just pick my answer from all the numbers. So my answer here is 7, and I could either write a equals 7 or just leave it to show the answer 7. 13, 1/4 plus 5/8 equals k, so I can change 1/4 to 2/8, and 2/8 plus 5/8 equals 7/8, which is equal to k. So k equals 7/8 there. Feels like we're going backwards a little bit, right? Because we just went through that whole weird thing with the replacement set, and now we're just solving like normal. All right, here, n equals 6 squared minus 4 squared. N equals 6 squared is 36, minus 4 squared is 16. 36 minus 16 is 20. Number 14. We're going to solve this fraction on top and on bottom. So 18 minus 3 is 15 on top, and 2 plus 3 is 5 on the bottom, and 15 divided by 5 is 3. And then I'm just going to do one more because you guys get the idea. K minus 9.8, sorry, K equals 9.8 plus 5.7. So I'm going to add these two together. 9 and 5 is 14. 0.8 and 0.7 is 1.5. 14 and 1.5 is 15.5. All right, so questions, let me know. Let's move on to the back side. All right, still on equations. Let me back up a little bit now so we can fit it all on here. Okay, solve equations with two variables. So these are two different variables, right? We're going to have like an independent and a dependent variable kind of thing, okay? So it says some equations contain two variables. It's often useful to make a table of values in which you can use substitution to find the corresponding values of a second variable. So if you had x's and y's, y equals 2x plus 4. Well, you can't solve for one of those variables unless you know what the other one is, right? So you make a little table of values, two columns, one column's for the x's, one column's for the y's. Pick which one you're gonna plug numbers in for, plug them in, solve, and then you put the answers in the other variable. So we're gonna practice doing that here, but we're kind of gonna work with like word problems. So this is good practice for your EOC. Music downloads. Emily belongs to an internet music service that charges $5.99 per month and 89 cents per song. Write and solve an equation to find the total amount Emily spends if she downloads 10 songs this month. So we know she has 10 songs. We know they charge $5.99 a month and she's only on 1 month. And we know they charge 89 cents per song. So we would write our equation in general without knowing how many songs that she downloaded. The general equation is total cost. And sometimes it tells you what variable you have to use. Sometimes you just pick. So it doesn't really matter as long as you know what your variable represents. So you could have used X here, it doesn't matter. But total cost equals 89 cents times however many songs you download. It's 89 cents per song. So if you download 5 songs, 89 times 5, plus a flat fee of $5.99. That $5.99 doesn't change. It doesn't matter if you download 1 song or 5 million songs. It's $5.99. So that doesn't have a variable attached to it. So now we want to plug in how many songs that she downloaded. She downloaded 10. So here they plugged in a 10 for the number of songs. So total cost equals 89 cents per song times 10 songs plus $5.99. That's $8.90 plus $5.99. When we add it together, we get $14.89. So total cost equals $14.89. And they wrote it out here. She spent $14.89 on music downloads this month. So that's all we're doing here for these word problems. All right, number 1, auto repair. A mechanic repairs Mr. Estes' car. The amount for parts is $48. Period. Flat rate. Doesn't say per whatever. It just says $48. So in our equation, we're going to write a 48. Done. No variable with that. And the rate, anytime you see a rate, you know there's going to be a variable, for the mechanic, for his work, is $40 per hour. So for each hour he works, he charges an additional $40. It's not just $40 for the day, right? If he works on it for 1 hour, that's $40. 2 hours, that's $80. 3 hours, that's $120. Depends on how many hours he works. Write and solve an equation to find the total cost of repairs for his car if the mechanic works for 1.5 hours. So our equation is, we'll just say capital C is total cost. The total cost is $40 per hour, or 40 times X, or you could say H, or whatever variable you want to use, plus a flat $48 fee for parts. Okay, so that's our equation. Total cost, we don't know it, so we use a C, equals $40 per hour. If we don't know the number of hours, that's X, plus a flat $48 fee for parts. And then we do know the number of hours. It tells us 1.5. So we say C equals 40 times 1.5 plus 48. And then we can start solving. 40 times 1.5 is 60. And 60 plus 48 is $108 total. His total cost for an hour and a half of work and parts is $108. Okay, number 2, shipping fees. Mr. Moore purchases an inflatable kayak weighing 30 pounds. So there's a number, so that's probably going to be important. From an online company. The standard rate to ship this purchase is $2.99 plus 85 cents per pound. So a flat $2.99. No matter what you're shipping, it's at least $2.99. And then for each pound they're shipping, because, you know, it's harder to ship heavier stuff, right? It's a lot harder to ship a kayak than to mail a letter, so it's going to cost a lot more money. So it's 85 cents per pound additional above and beyond the $2.99. Write and solve an equation to find the total amount he'll pay to have the kayak shipped to his home. So we'll say total cost equals $2.99 plus, and then 85 cents per pound, 0.85 per pound. Now, a lot of times, kind of the correct way to write this is always to put the variable term first and then put the number that doesn't have a variable attached, just hang it off the end of our equation, right? But it doesn't really matter when you're adding. It doesn't matter what order you do it in. So if you did it this way, you're correct. If you did it 0.85x plus 299, that's kind of the more, like, the correct way to do it. That's the way you're supposed to keep it. But either way, you'll get the same answer. Okay, so here we know that his kayak weighed 30 pounds. So in place of x, we're going to put a 30. 299 plus 0.85 times 30. And then we can solve. So 30 times 0.85 gives us 25.50. So 299 plus $25.50 equals $28.49. And I'll move this over. So it's going to cost him a good almost $29, right? $28.49 to ship a 30-pound kayak. It's a lot heavier than having to ship a letter, right? All right, number 3, sound. The speed of sound. And some people, like, I don't know, I'm one of those people, I'm an overthinker. I overthink everything. Like, I'm terrible at test taking because I'll sit there and talk myself out of an answer and then I'll talk myself back into it, and it's terrible. But don't overthink problems. Like, if it's a money problem, don't start thinking, okay, well, that's the total cost, but then what about tax? And how do I know what tax is? Is it 6% or 7%? If it doesn't mention tax, don't put tax in. Don't add stuff on if it doesn't. Take it for face value. So here, speed of sound. Some people want to start using rate, like distance and rate, and, rate equals distance, whatever. You guys want to start doing it? No, it has nothing to do with anything. Literally just take what it's telling you. The speed of sound is 1,088 feet per second at sea level at 32 degrees Fahrenheit. Write and solve an equation to find the distance sound travels in 8 seconds under these conditions. So this has nothing to do with the math problem. It's just, if these are the conditions, here's the information. So this kind of cancels each other out. So don't let numbers in an equation confuse you when they're not even important to what we're doing. Those go away. So the speed of sound is 1,088 feet per second. Write an equation to find the distance sound travels in 8 seconds. Okay, so we're going to say distance equals 1,088 feet per second. So I'm going to do times S. Okay, and then it tells us that it's 8 seconds. It wants us to tell how long, what the distance is sound travels in 8 seconds if this is the rate. So distance equals 1,088 times 8 seconds. 1,088 times 8 equals 8,704. 8,704, and that's in feet? Feet per second, yeah. Feet. At 1,088 feet per second times 8 seconds, it travels a total of 8,704 feet. So we got our equation and we solved it. And then lastly, number 4. My battery's low. Your town decides to build a volleyball court. If the court is approximately 40 by 70 feet and its surface is of sand 1 foot deep, the court will require about 166 tons of sand. I'm going to give you a little hint as we keep reading. You're going to find out that this whole 40 by 70 feet thing, and it's a foot deep, doesn't matter. It's just telling us that's where they came up with this number, but this is the number that's important. So we don't care how they got it. This is what we're looking at. A local sand pit sells sand for $11 per ton, and then they deliver it at $3 per ton. Write and solve an equation to find the total cost of sand for the court. Okay, so your town decides to build a volleyball court, and if the court requires that much sand and delivers it at $3 per ton, so really we could say that the total cost equals $11 per ton, plus it costs $3 per ton to ship it, right? Well, if you're automatic, and it's not really shipping, it's delivering it. So if you need it over at the volleyball court, you're not hardly going to put it in the back of your pickup truck, like, little bit by little bit, and deliver 166 tons of sand that way. You're just going to get their big truck to show up at the volleyball court and drop it off. Well, they're going to do that, but they're going to charge you $3 per ton for that. So you're already paying for each ton, $11 per ton, plus you're paying a $3 delivery charge per ton. So really you're paying $14 per ton of sand to get it delivered and everything, and to own it. So if total cost equals 14x, and you know that you have 166 tons of sand, that's x, that's per ton. So 14 times 166 equals, handy dandy calculator out, 2324. $2,324 to purchase 166 tons of sand and have it delivered. It's going to cost you that much, right? So everybody see how we came up with the equation and then how we solved it. If you guys have any questions, shoot them my way. Make sure that you fill out the practice worksheet. I think it's even numbers only. It's a one-sided worksheet. You just have to do the even problems. And then you have a word problem sheet that has, I don't know, between 6 and 10 problems on it. They're word problems like these, and you're going to do all of that. Okay, so you're going to upload both of them together. I don't care if you write on your own paper or if you print out my worksheets and write directly on them. I don't care either way. You can download them in one file and upload it in one file, so I can grade it like on one sheet of paper. Or you can have 2 sheets of paper and upload it that way. I can look at both of them, however you want to do it, but make sure you get those handed in.